Hello. So this is a introduction to testing using the KISS API. So this is a Hello World program using this KISS library that you get from github.com/wmcavoy/KISS. And this is how that would work or look. Um, there's an introduction to getting this all installed. If this is totally new to you, you can look at the video on just hello or hi, and you'll see that far. But now I want to focus on introducing the idea of testing, and to do that I'm going to test this application and then go on and test a small, like, buying lunch kind of application. Alright, so here is our hello world. If I run it, I see my hello world as output, and that's that. So now I'd like to just add a test that verifies that it's working. So the typical thing is you say test and some method name that hopefully is useful, and then to test that a certain output is created. If it's a simple message like this, the simplest way is to create essentially an expectation. So the way that works is from your output, expect hello world, like that, when I invoke run. So the way this test, let's just verify that it runs now. So now I have a test called test run, and apparently it ran, and then after it ran, it went ahead and invoked hello world by itself to see the message. But now this is tested, and the way to interpret this code is this is called a try with resources. So you try to create an output file, an output stream, where that output stream is expected to produce this kind of output, so hello world. And so now when you run inside of here, the output that run produces, instead of being just shown on the console, which is what happens, say, the second time it's invoked down here when it prints out hello world, but inside of the test, the run's output, this println statement, is checked against what is expected to be seen, in this case the word hello world, and so when that happens, if it all works out, you just don't get an error, and it's just proving that in fact when I run this method I see hello world. So to illustrate what happens if there's a mistake, I'm going to put a question mark in here. So now I was expecting hello world with an exclamation point at the end, but instead in my actual run method I should say, instead I put a question mark, and so if I try to run that, I suddenly get a bunch of red ink, which is a representation of an error. And if I kind of look through here, it says there's some kind of assertion error that happened. Here's the test run, so I know that it came out of this test. Something failed in there. So this is me as like trying to show you what things to look for when you see failed tests. So the first thing to notice is which test failed, and it'll tell you which one started here. And so it says some kind of assertion error, some test failed, okay, and then caused by, that looks kind of hard to understand. Here is something I hope you notice. So there's a verify exception, verify runtime exception. So a verify exception is what happens when you expected some kind of output and the verifier could not verify that that's what happened. And there's some useful information that comes out of this line. So the verify runtime exception says that there's a mismatch at byte offset 12. What does that mean? Well, so every character that's sent to the output counts as a byte, starting from byte offset 0. So byte offset 12, looking down here, so H would be byte offset 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, look. So byte offset 12 is the question mark, basically, of when the print lines happen. And then it says expected, an exclamation point. That's Unicode character code 33, or code point 33. But instead I got a question mark. And if I keep on sliding across, that's a different code, and the number itself doesn't matter that much. But what matters is in my test, somehow I expected a bang to show up, and instead I got a question mark. And that seems like pretty useful information there. So I know what test failed. That starts right there. Test run started, and then the error. Then if I go down here and I see a verify runtime exception, well, it has something to do with output that mismatch, and it tries to give you some details about what went wrong there. All right, and then if I keep scrolling down in here, sorry, here's our own code, so app.run and app.testrun. So if I click here, app.run, well look, it actually takes you to the line that generated the error. So here, this is the program, the part of the program that actually had the problem in it. And it's not always true that you're going to get exactly to the line of code where the problem is created, but it tries to get you as close as it can. And then and the last part is if I go into a test run, no, that's a little bit too far down, isn't it? Did that happen anywhere else? Should see where. No? Huh. Alright, so then the closest we get there apparently is, oh no, that is the right line. Test run Java. So this is where in the test it failed, right? This is where in the tested part there was a failure. This is what it expected to see versus what it got, and how many characters over essentially that happened. Each ln in a print ln counts for 1 or 2 bytes. That's, I guess, the almost part. So on everybody but Windows, ln's count as 1 byte. In Windows, because that is used, 2 code points are used for the end of a line, you get 2 bytes for each one of those. So you have to, that's the counting that gets a little bit complicated, but that's just the differences between the two Unix versus non-Unix sort of systems. And then finally, what's the name of the test that was started, that started the whole business? So in this case, at the top, test run started. So it's this test run that was being run. It got to here. When it got to here, there was something wrong between a question mark and an exclamation point, and it was in this method that it happened. So that's a lot of information, I hope, that will help you clue into where the problem is. Obviously, like, this is the freight train, like, we know exactly what the problem is, so let's just fix it. When there are no problems, then instead you just don't get any messages. So automated tests tend to be relatively quiet, because if you have a lot of them, you don't want to see too much stuff going on. So this is just an indication that it passed and how long it ran, or how long it took to execute the test. And then after that, running the hello world. All right. So now let's try, if that's output, then how do you get some input into here? So string. So now we're going to have a little bit of input from the console. So now we're going to ask the user to type in a name, and instead of this world, we'll respond with hi and whatever name was typed in there, followed by an enter. And so we will, just to illustrate it before we test it. So a nice habit is just put an un in front of the test to turn off a test. So now this is now just going to execute the run. Oh yeah, no output, because now it's just waiting for me to type something. I type Alice, and it prints out hello Alice. So how do we test that kind of a program where you're sending in some information and then you're expecting something out that depends on that information? So so suppose we wanted to provide Alice to that thing, to that little run method down below. Then close, not int, but in, close in, provide name. So I hope that that feels pretty analogous to what we just saw in there. Try, there we go. So if we want to, oh, and we can't say hello world, that's not what we expect anymore. What we expect is hello name, like that. So here's a little test now turned back on. So if I provide name, and by default a provide effectively is like typing in that followed by an enter, pressing enter. So if I provide that kind of input, then I should expect this kind of output from invoking this method, invoking run. And so here's my run method, and here's my new test run method that both tests input and output. And if I run it, and then it just passes, and here if I provide a name, it still says hello Bob. So this is a typical transaction with my hello down below. And then after that, after it passes all the tests, it goes ahead and runs it, which is great. So having to type a name every time I run this program isn't that great, and so I want to avoid that and just give this a more generic name like hi. Because there's nothing wrong, in fact it's a great idea to test all the little components of an application. I imagine that some little part of my program wants to say hello to the person that says their name. I now have a way to test this hi method, and if I run that, I get a test, and the build successful, so my whole execution finished. And what happened was this automatic test kind of took this and ran it through its paces and gave it an example input, provided that example input, expected a certain kind of output, and then the fact that it finished the test means that in fact all that worked out, and so now I have a lot more confidence that hi is doing what I wanted it to do, and therefore I could use it elsewhere and have greater confidence that it will actually work. And that's the one really important part of what testing means, is to go ahead and have confidence in the things that you build. So that's important to provide tests that build up that confidence as you go. So there's the first simple testing where you have a certain kinds of input versus certain kinds of output, and I wanted to illustrate how that worked. So now I'm going to go on and test kind of something completely different, but just to leave them in there as some illustrations, I'm going to leave that test in, and we're going to test a little lunch money scenario. So imagine wanting to decide whether you can go buy lunch at the cafeteria, and in that case you have a certain amount of money in your pocket. Oops, not money has decimals, so double. So you have a certain amount of money in your pocket, and you have a certain amount of punches in your lunch punches. It's some little card, or maybe a swipe thing that this is how many punches are available. All right. So those are two little facts that are just the state of your life, right? How much money is in your pocket, and how many punches are in your card for getting to the cafeteria. So then if you have that kind of information, then you should be able to ask a question like, can you go buy lunch? So let's make what's called a method that returns a true or false, a Boolean value. Can buy lunch. And then in here we'll put the logic that will use the state of the world, how much money you have, and how many punches you have, and decide whether or not you really can buy lunch. So let's see here. So let's assume that lunch costs at your cafeteria costs $5.50. So if your money is bigger than $5.50, then you can buy lunch, right? And then, so that's great. So if you have money, you can buy the lunch ticket, or buy a lunch directly. The other way you could buy lunch apparently is if you have enough punches, which one should be enough. So if punches is greater than 0, then you should be able to buy lunch. And otherwise, I guess you can't buy lunch, so return false. So here's a little method called can buy lunch. You don't hand anything over to it, no additional information. It returns a true or a false. This is why the Boolean is sitting right here. And then here's the check. So if there's if you have more than $5.50 in money, then that's good enough. If you have punches, then that's good enough. And then let's just check to see whether that works. And so it's not built until you got it tested. So void test can buy lunch. So here's a little test method to try to test it. And what we do is we create little artificial scenarios and see how things work out. So suppose you have a $10 bill and you have no punches. Then it should be true, and that's called an assert. It should be true that can buy lunch in that case should be true. Right, because you have enough money for lunch. So that should just work out, right? The next one would be money. What if you don't have enough money? You only have $2.75, but you do have some punches. Then in that case, well, you can still buy lunch, right? Can buy lunch is still true. All right, and then that should work out. Well, if you don't have enough money and punches, and you don't have enough punches, then in that case, well, that should work out. I mean, that should be the only case so far that you can't buy lunch, is you don't have enough money, and off we go, do the test. Look, we passed all the tests. So so I guess I want to point out that there is actually a small error in here, and this is very typical. You know, people who build tests will sometimes miss cases and say, oh yeah, what about that case? And it turns out the logic isn't quite right. So let me just point out that here's a test case that fails. So what if you have exactly the right amount of money? So money is equal to 550. So you'd have just enough money, but you have no punches. You should still be able to buy lunch. I mean, you'd spend all your money, but you'd get it, right? I mean, that seems like that should be true. So it should be true that you can buy lunch if you have that, right? But if we run that, like bam. All right, so this is what's called a sort of a regression. So you've discovered, like before you only had these 3 tests essentially of cases of how things would work, and then someone goes in, or you ran it, in this case, like, you know, I understand why this person had exactly the right amount of money and still they couldn't buy lunch. And it's like, oh, that's surprising. So you add that, this is a new test, you add that test to your suite of tests and say, well, look, I mean, really that should work out. So now I have a way to validate whether that I need this feature. Like, you can't really justify that this, well, it's like, you know, it really is a problem. This should be true, that if you have enough money, that should work out. So I should go back and adjust my implementation, hopefully, until it is true. And this is called test-driven design. So I have a test that fails now. And by the way, if I go down here, assertion error caused by, go here, it takes me exactly to the line of code where the failure happened. And of course, I know which test in my can buy lunch is where things broke. And so I now hopefully can zoom in on a case. It's like, well, that's interesting. So now I can go up here and say, oh, well, look, it's not only if money is greater than 550, but equal to 550 is perfectly fine. So if money is greater than or equal to 550, then return true. Then that's a better implementation of can buy lunch. And so now if I run go, yay! Look, I passed all my tests. So this is an improved implementation compared to before, and this is quite good analogy of how a developer can move on and build code. Is as you find problems on ongoing implementations, you try to add to your tests to show that case of how things worked or did not work out, and if they fail, then that's kind of a good thing. Like you've now established that this is a problem that you've discovered in your code. It's important to somebody. And so then you can go back and get to the point where that works. And what's great is now you have in code something that validates that it's going to be good kind of forever, right? So every time I change implementations, I still have all these tests to make sure that any new implementation is still fine. So to illustrate that idea, there's a much shorter way of writing essentially the same idea here. And so I will write it. And what's great about it, so return money. So this is using the logical operators of OR. So really, all that if stuff could have been turned into this one logical expression. So can buy lunch, well, that would be true if the money is bigger than or equal to 550. That's the important change that we discovered by the added test. Or we have more than 0 punches. So if either of these conditions are true, then it would be true that we can buy lunch. And this new implementation is much smaller as far as the amount of code we have to write. And for someone who's reasonably good at reading logic, it's actually quite clear what it means. And so this is not just some sort of obscure, hard to read bit of code. Once you're used to the logic operators of the language, this is actually quite convenient, and I'll say easier to read for someone who's used to the language. This is easier to read than the if statements. So if I run that, the great thing is, see, now I pass all my tests still, and so I'm confident that my new implementation is at least just as good as the old one, in the sense that it passes all the same tests. And this is a really important benefit of having a bunch of automated tests. Is it really makes it easy to try different versions of implementing things. And if it's like if this one might be better, it might be hard to retest everything that you had before. But if you have a bunch of automated tests like this, then it's kind of easy to swap out ideas and then just retest and see whether all my old version of test still worked out. So it must be that this new version is just better. Maybe it passes more tests than it used to, or it's just faster, easier to read, something like that. But it makes it much easier to improve your code if you have a good set of tests. All right. And I think there is one other thing that I'd like to add to this, and that's the idea of a constant. Before I move on, and that's it kind of bothers me that there's this number 550 peppered in here, and it would be an easy thing to imagine that the price of lunch at the cafeteria would change, and then suddenly I'd be looking through my code trying to determine where did that matter. And so that's a good example of a constant. So here's how you declare a constant in Java. So it's kind of a lot of typing, but it is the static. You use the word static, and then final, and then the type, like double in this case, and then price, say. Usually they're capped. I don't know why shouting is such a great idea, but they are usually the cap. So price is a double. The static means it's really that there's only one of them in the world. There's one price to worry about, and then there's money and punches. So final double price equals 550, like that. And now instead of money is greater than this, I can stick to price there, which is I think easier to read. If money is greater than or equal to price, then punch it. Yeah, that is somehow easy to read, right? And then down here, my test is if the money I have is exactly equal to the price of lunch, then you should be able to buy lunch. And this is called a boundary case, right? So when you think about when the logic of how things work switches from being true to false or different branches of how things execute changes, those moments, those values that cause differences in how things go are called boundary cases. And you should check boundary cases to make sure that they worked out. In fact, the fact that I didn't have a boundary case before is why I had actually an error in my implementation, is I didn't really check that boundary of what happens if I have just exactly the right amount of money. That's called a boundary case, and I should test it. All right, so if I run this, still works. And what's nice to me, and this is really not just a testing question, but if you have a value that really means something, not just a bunch of numbers, a really good idea is to give it a name that is useful to you. In this case, price is a pretty good name, and that way later on you can use it. And if it changes at some point, you just have to change it in one place, and it makes the rest of the code a lot easier to read because it doesn't have what most people call as magic constants in the code. All right, so that's can buy lunch. So let's add one more test. So this is testing the features of one method, right? And so now let's try buying lunch. So buy lunch. Now that we have that constant, all this is going to be a lot easier to read. So let's say our rules for buying lunch is if we have any punches left, if we can use punches, we will. So if punches is bigger than 0, I have some punches, then decrement the number of punches I have. So that's minus minus is the decrement operator in Java. So decrement how many punches I have, and that's it. So that works. That's how I buy lunch if I have some punches. And then if I have enough money, so greater than equal to price, then money, you don't want to decrement. So decrement is subtracting 1. So money, I want to subtract the total price. So the way you write that is like that. So if money is bigger than or equal to the price, then go ahead and subtract that much from the amount of money I have. That should still leave at least 0 money left, and that's a way out of that. So return means get out of buying lunch. So get into buying lunch. If I have some punches, take 1 punch, and then that's done. So return from this buy lunch. If that doesn't work out, then if money is bigger than the price of lunch or equal to, then remove that much money from my pocket basically, and then I'm done there. And then that's an interesting thing. So now we're down to, well, what if neither one of those things worked out and I was asked to buy lunch? That's in Java, that's an error. So new error, can't buy lunch. So when you're into a case of like this should not happen, that's an opportunity to throw error cases. So this is going against the normal flow of how things should work out, and then what happens is like, well, that really shouldn't happen. So there's a bunch of other kinds of particular kind of errors you can send out, but the simple thing just to get started is if you're to a spot where things shouldn't have gotten to, you can just throw an error and say, well, I shouldn't have been there. So so that's a what looks like a pretty good implementation. Let's see what it'd be like. So we'll go take our tests from can buy lunch. By the way, I don't want to pile them all back into there. It's a good idea to make tests into little useful subblocks so that you can look at each piece and see, what things being tested and kind of what particular case might have failed. So test not can buy lunch, but now we're going to test buy lunch. So if I have $10 and no punches, then I try to buy lunch. So buy lunch doesn't hand anything back, so I just have to try it. So I try to buy lunch there. Then if I have this setup, I try to buy lunch, then it should be, well, then apparently I spent money there. So now I can assert that your punches is still equal to 0. That shouldn't have changed, but my money should be equal to $10, the original price, the original value minus the price of lunch, right? So that's what should work out when I try to buy lunch with this. All right. So what about this one? I have $2.75 and I have $2. Then and then I try to buy lunch. Let me grab that code right there. Okay, so if I have $2.75 and 2 punches, then it should really be true that I just use a punch. So I go to 1 punch, right? But I don't spend any money, so it should still be $2.75 like that. Okay, so if I have money, not enough though, and then I have 2 punches, then what should turn out is that way. All right, so now how about this one? So this is an interesting one. So if I try to buy lunch here, I'm gonna put a question mark. I'll get to that. I'll call that an advanced topic. Like this you shouldn't even try to buy lunch, right? If you don't have enough money and you don't have any punches, then that's a problem, right? You don't have money, you don't have punches, you buy lunch, bad. So let's see if we can get to that one. later. So that's a special case, because you shouldn't even try to buy lunch if you don't have that much money. But well, I'll leave this last case in because this is one where buy lunch actually should work out. So if I have just enough money, then it should be that assert the money should be 0 in that case, and then assert that punches should be 0. Okay, so the only one that is a little tricky is what if we try to do something that should just totally fail. So let's not do that to start with. And here's the 3 ways that buying lunches seem to make sense. So we have plenty of money, but no punches, and we should use some money. If we have enough punches, we have punches. I guess that's a boundary case too. We should try. We have exactly 1 punch. That seemed like a good boundary case to put in there, huh? So let's put that in there. So that's testing is hard. You have to usually as you go along, you keep on adding tests to the whole business, and that's just a comment slash. Wow, hard to write comments sometimes. Okay, so here's I wanted to add 1 extra case. So money 275, money 2. So if we have exactly the right number of punches to buy lunch, then we should just be out of punches after we're done. But that should be fine. But that'd be a boundary case on the punches, right? Do we have enough? If we have just 1 punch, then in the end it should work out, right? So let's just test it. Oh, look. So all my buy lunches worked out. And these are all tests of how that should work out. Testing things without creating exceptions, like that throw error as an exception, is an important thing to make sure that the places where the normal behavior of your methods are working out. It is often a little trickier to find out how things work when they break, and so I'll say if you want to, you can ignore this case. I'm okay with this, but I'll call this an advanced topic. But let's just add what happens with this error. So first, let's just throw the error. It would be nice to see what happens, right? So we don't have enough money and we don't have enough punches. This should be some sort of bad thing, right? So this is bad thing. Run, we get redness, and look, caused by error, can't buy lunch. So we set up a scenario where you really can't do this, right? And so let's that's actually our goal in that case. Is really we wanted a bad thing to happen, and so we want to try and catch that. So try to buy the lunch here, and what we're expecting is catch error, catch this error like that, and then I guess here we'll just say something like past equals true. Can't do it else. That's a little too bad. So assume that it didn't pass this test that we're trying to set up, and so try to buy lunch, pass equals false, and then finally in here what we can do is assert pass is equal to true, like that. So set up that pass is false. This is a pretty advanced test, really. We're setting up where we really shouldn't have gotten through buying lunch, so not enough money, not enough punches. We try to buy lunch, and what now I'm expecting is that I catch this. I try to do this because I'm expecting to catch an error, and the error is going to be the can't buy lunch error, right? And so so if I catch the error, then that actually is what I expected. Otherwise, I don't catch an error, then well, that means something bad happens, I shouldn't be able to buy lunch if I didn't have enough money. So if I didn't get into this catch, this pass will stay false. And so the only way I really get all the way past this assert at the bottom here is if, in fact, buy lunch through an error, which is what I want, right? I'm actually testing an error condition, and that's a trickier thing to test. So here I'm testing an error condition that, in fact, when I try to buy lunch without enough money, I get an error. So let's see, now we should be all green again. So so this is a kind of an inverted test. This is trying to make sure that something breaks in the right places. So if I don't have enough money and I don't have enough punches, then I definitely should get an error from trying to buy lunch. And so here is a setup where I should get the error. I then catch the error. If that's true that I do catch the error, then, well, in this very odd sense, even though I got an error, it's the error I wanted, so I'm going to call that a pass. And then down here, I'm going to verify that, in fact, I did catch the error, so there's a pass equals true. So this little block of code just checks for an error condition that I was expecting to see out of a method, and that's a fairly advanced test. And it uses what's called a try catch block. So here's where you're trying something where something bad might happen. Here's where you're trying to catch the badness. And in this little block of code is what you're doing if that bad thing does happen. In this case, it's like, well, that's actually good. That's what we wanted. And down here, we're going to verify that, in fact, it all passed. So so now we have a nice set of tests for buying lunch, and we have a nice set of tests for can buy lunch. And down in here, at some point, we now can, with confidence, use those methods in a bigger context where we can confidently say, well, can buy lunch is just a question we can ask, and buy lunch is just an action we can do, and trust that they're going to be doing the right things. If, as we use them, we find out that that's no longer right, that there's some logic error or something like that, what we should do is add more tests to verify the logic in the places where it seems like it's failed, and then improve the logic, and then that sort of growth of tests along with code that hopefully pass more and more of those tests is an essential part of testing an application. All right, so kind of to recap, so here's a typical test case where you set up some conditions before you run something, you execute a method, and then just assert that after you've set it up, you're seeing the outcomes that you expect. So that's quite typical with asserts for a sort of a test case. Here's a pretty advanced test where you're actually expecting some kind of an error, and so in this case, you set up a case where it should sort of blow up and throw an error, and then you invoke the method, you expect the error to happen by catching it, and then just check that, in fact, this logic makes sure that, in fact, that error did happen, because that's the thing you want it to have. So and here's various different cases, including boundary cases. That was important. Each name of a test should be a little short explanation of what things you're trying to test. You shouldn't put too many tests in each block, and they certainly should have a common theme. If they don't have a common theme, then they should just have different names, so it's easier to tell what things went wrong when you see errors. So each method or each kind of part of your test, part of your application should be tested independently. Those are little block tests or unit tests, although that word is used in a slightly different meaning, but don't worry about that for now. But you're trying to test kind of the smallest components you can of the functionality of your application. And then going way back to the beginning, here's our test high. If you have certain inputs and then corresponding certain outputs, and you want to test that kind of a functionality of some method in your application, then here's the setup. So you try to create an expectation of what output you get with providing the right input. So providing the right input to this high method, this is what I expect to come out of it, and there's a little test of all that. And then under the framework, it just runs all the tests. I could add a run method that would exercise those methods now that they've been tested, but there's also nothing wrong with just making sure that all the parts work. Maybe it's somebody else's job to integrate these all into an application. Thank you very much. And testing's a big deal. I hope that you write tests. They really help you build better software.